to remember when you're working with trig functions. Calculator in radian mode. Sometimes we do these questions in radians, sometimes we do them in degrees. Okay? Every time you see a pi for one of your angles, you know that we're working in radian mode. Okay? If it doesn't specify, kind of assume that we're working with radians here. You got to remember these special triangles, 1, 1, root 2, 1, 2, root 3 for our pi over 4, our pi over 3, and our pi over 6 angles there, if it asks for an exact answer. There's the cast rule that you started working with back in grade 11 that tells you the sign of each of these trig functions in each of the 4 quadrants. Okay? And you have to remember that a lot of times you're working with your reference angles and you have to apply the cast rule to figure out what the sign of your answer is going to be. Okay? So just keep all of those things in mind as we go through these examples here. First example. Find the equation of the tangent line to the curve y equals sin x minus cos x squared at the point x equals 5 pi over 4. Okay, so this is a standard question. I mean, we've asked you a million times how to find the equation of a tangent line. We're just giving you a trig function now. So what is our first step? You're going to do the question? All right. Yeah, so let's do our derivative first. Okay. Let's see, sin x minus cos x all squared, so we'll bring down the 2. We'll have sin x minus cos x inside the brackets, and then we need to multiply this by the derivative of sin x minus cos x. So we can do this term by term. Derivative of sin x is cos x. Derivative of minus cos x, well, let's see, we can subtract the derivative of cos x. Derivative of cos x, though, is minus sin x. And so we get cos x minus sin x, or cos x plus sin x. So sin x minus cos x times cos x plus sin x. Now, at this point, I'm going to multiply this out. I'm going to expand it because I know that because I have the same 2 terms here, sin x, cos x, one positive, one negative, I'm going to get some terms that cancel out. So this is going to work out to be 2 sin x cos x, but I'm going to have a minus sin x cos x that cancel. So I'll end up with sin squared x minus cos squared x after I do that expansion. If it was a plus sign in the middle, it would be equal to 1. But it's a minus sign. Alas. So we've got our derivative here. What do we want to do with our derivative now that we have it? So we sub in x equals 5 pi over 4. So what I would do is I would evaluate sine 5 pi over 4 and cosine 5 pi over 4, okay, because they both appear in my expression here, and then evaluate what the whole derivative is going to be equal to. So 5 pi over 4. What does this angle even look like? What quadrant is it in? It's got to be in the 3rd quadrant, because 4 pi over 4 would be just pi, which would be 180. So it's got to be down in this quadrant here. And our related angle, or our reference angle, in there is pi over 4. So if we want to do this exactly, we've got to use our special triangle for pi over 4, which is our 1, 1, root 2 triangle. And he draws a square root in there. Let's just do pi over 4, 1, 1, root 2. And that's a horrible looking triangle. I'll put an arrow. Pi over 4. So if we're doing sine, we have opposite over hypotenuse. So 1 over root 2. But we're in third quadrant, so we apply our cast rule, which tells us that only tangent is positive. So this has got to be negative 1 over root 2. Cosine, we've got adjacent over hypotenuse, which is again 1 over root 2. Apply the cast rule, only tangent is positive, so this is going to be negative as well. So we've got sine 5 pi over 4, we've got cosine 5 pi over 4. Let's work out what the value is of our derivative. It's going to be 2 negative 1 over root 2 squared minus negative 1 over root 2 squared but since sine and cosine are exactly the same, those are going to cancel out and our derivative is just 0. So what does this tell us about our line here, our tangent line? It's horizontal, exactly. So where do we go from here? We want to get the equation y equals mx plus b. We know that we can already sub in 0 for our slope. What we still need is x and y. We know that x is 5 pi over 4. Y is going to be, well, let's go back to our original function here. Our original function was sine x minus cos x. So it's going to be sine 5 pi over 4 minus cos 5 pi over 4. And this whole thing was squared. We already know what sine and cos of 5 pi over 4 are because we evaluated them up here. So we can just sub in those values there. We get negative 1 over root 2 for each of these. And we're going to square this. And what do we get here? 0 again. So what we get is 0 equals 0, 5 pi over 4, plus b. B equals 0. So y equals 0. So our tangent is just the x-axis for this one. All right, so standard type of question here. The other kind of question we like asking you. Find the local maxima and minima of this curve, y equals sine x plus cos 2x over some interval. What's our first step here? Derivative. So our derivative, we can do this term by term. Derivative of sine x is cosx. Derivative of cos 2x is going to be, sorry, not cosx, but negative sine 2x times 2. Where I'll put the 2x in brackets there. Okay. And so the equation we need to solve here is, we set it equal to 0. 0 is going to be cos x minus 2 sine 2x. Now, what's tricky about solving this the way it currently is formulated? Convert what over to cos? Yeah. Yeah. Yeah, the problem we have here is that this is cos x and this is sine of 2x. Okay, so these trig functions don't have the same argument. So what do we do in these cases? Well, we have to apply an identity to get it so that both of these are the same. So the identity that we're going to apply here looks like this. Okay, this is going to be 2. Sine 2x is 2 cos x sine x. So there's our identity. Let's see. So we've got 4 cos x sine x. Now what should we do? Yeah, we can factor out the cosine, which gives us 1 minus 4 sine x. So this gives us two equations that we can solve. We can solve cos x equals 0, and if we rearrange the stuff in the square brackets, we get sine x equals 1/4. And these are our two things to solve. Cos x equals 0 is pretty straightforward, because we can just think about what the graph of cos x looks like. Where does it reach 0? It reaches 0 at pi over 2 and 3 pi over 2. I know that I have to work in radians because in my original question, the domain was given to me in radians. What about this one over here? Sine x equals 1/4. This is one that I'm going to have to solve. Go ahead. Yeah, I've got to do this one numerically. Just plug this into my calculator. Inverse sine of 1/4. Now, I punch this into my calculator, and I get 0.253. Is that the only solution? Brody's shaking his head. What do we have to consider here? Yeah, the domain, yeah, which goes 0 to 2 pi. So we have to think about, yeah. Your calculator is always going to give you, if this is positive, it's always going to give you the quadrant 1 solution. So this is the solution that we have right now. Where else can the sign of x be positive? Well, let's see. Cast rule tells us, C-A-S-T, that we're also going to have a quadrant 2 solution. So what's our quadrant 2 solution? Well, this angle in here will be the 0.253. So x is going to be pi minus 0.253. Which gets us 2.889. So we've got our solutions here. 4 of them. 2 of them we have exact. 2 of them we got numerically. Well, we go back to the original question here and we see what it's asking us. Find the local maxima and minima of this curve. So we need to figure out whether these critical numbers represent local maxima or local minima and find the coordinates or the y values. What can we use to figure out if these are maxima or minima? The second derivative test. So we are going to use second derivative test. So we need our second derivative. So I'm going to go back to our first derivative here, and if I just scroll up here, I think where we want to take the second derivative is after we've applied our identity, but before we've started factoring. Okay, so I'm going to start at this point right here where we have cos-x minus 4 sin x cos-x. And I'm going to do the derivative here. So our first term is pretty straightforward. Derivative of cos-x is negative sin x. Then we can subtract 4 times the derivative of sin x cos-x. Sin x times cos-x. We've got to use product rule here. So derivative of sin x is cos-x times cos-x plus derivative of, we've got sin x, our original u function, times derivative of cos-x, which is negative sin x. So we can clean this up a bit. Negative sin x minus 4 cos squared x. Sin x times sin x gives us negative sin x squared times negative 4 gives us plus 4 sin squared x. And this is what we have to evaluate for each of our critical numbers. So probably what you would do is just do this numerically. Punch these things into your calculator. So if x is pi over 2, figure out what y double primed is. And I've done this. Y double primed works out to be 3. So if y double primed is 3, this is positive, which means we have a local minimum. Okay, and we can work out what our y value is from our original function. And you work that out, and you get a y value of 0. Okay? And we want to do the same thing for each of our points here. So x is 3 pi over 2. We get y double primed is 5. So we have another local minimum. And our y value there is negative 2. Then those are our 2 exact solutions. Then we've got to do it for our 2 approximate solutions. So those were 0.253. We get y double primed is equal to negative 3.7. And it doesn't matter how accurately I get this second derivative, because I'm only really interested in the sign. So my sign here is negative, so this is going to be a local maximum. And I go ahead and I work out my y value is 1.125. I've got 1 point left to go here. It is 2.889. My second derivative works out to be negative 3.7 again. So I've got another local maximum, and my y value works out to be the same thing. So I could sort of sum all this up by saying, therefore, we have a local min at pi over 2, 0, and 3 pi over 2, negative 2. And we have a local max, two local maxima at, and then just put in our approximate values here. 0.253, 1.125, and 2.889, 1.125. And I don't have room for the 5. Okay. And that's what they were asking us for, the local max and the local min. Okay, so we're done.